So, today we are going to learn gravitation. Let us begin with some questions. So, why does Earth revolves around the Sun? Or why does Moon revolves around the Earth? These questions can be answered by knowing gravitation. So, what is gravitation? There is a very interesting story regarding gravitation. We all know that once upon a once Sir Isaac Newton, the great physicist, was sitting under an apple tree and he observed that apples were falling down. Okay, now one question came in his mind: why apples are not going up? These questions lead him to the discovery of gravitation. Okay, and the same thing he related to the revolution of Earth around the Sun or revolution of Moon around the Earth. What he told, that apples are falling down due to the attractional force of Earth, and in the same way the attractional force of Earth is the cause of revolution of Moon around the Earth. Let us take a stone and let us take a stone tied with a thread. Okay, now let me whirl it around my finger. So what we'll find, that it is moving in a circular path. The stone will move in a circular path. Now if by chance this thread will break, then what will happen? The stone will fly in a direction tangent to the circle. Correct? So this stone is why not flying away from this finger? Because it is tied by this thread. Newton told that in the same way Moon is tied with the Earth. If it is the Earth, Moon is also tied with the Earth by the attractional force of Earth. And this force is known as gravitation. If this gravitation force would not be there, Moon can also fly away in a direction tangent to the circle. And this gravitation force provide the center seeking or centripetal force to the Moon, which causes it to revolve around the Earth. Then Newton concluded that the gravitational force is not only limited on Earth or Moon, it is applicable to each and every particle on the universe. And then he gave the definition of gravitation, that in the universe every two objects attract each other with a force which is directly proportional to the multiplication of the masses of the objects and inversely proportional to the square of the distance between the center of the objects. So what Newton explained, that if there are two masses, let m1 and m2, okay, and the distance between the center of m1 and m2 is, let smaller, then Newton told that m1 will attract m2 by a force F. In the same way, M2 will attract M1 with a force F, and that F is directly proportional to the M1 into M2 and inversely proportional to the square of the distance between the center of the two objects. Means these are the two equations. Now, these are the two equations. Now, after equating these two equations, we will get F is proportional to M1, M2 by R square. Now, if we take G, capital G, as a constant of proportionality, then F will be equal to G M1 M2 by R square. Okay. This constant of proportionality is known as gravitational constant. Okay, so G is known as gravitational constant, and the value of G is equal to 6.6 into 10 to the power 10 to the power minus 23, sorry, minus 11, 10 to the power minus 11 10 to the power minus 11 Okay. Now, what will be the unit of G? If we put the unit of force, that is Newton, and unit of distance is meter, unit of masses is kg. So unit of G will be Newton meter square per kg square. So this is the value of G, known as gravitational constant. And this law given by Newton is known as universal law of gravitation. After giving the concept of universal law of gravitation, Newton explained the weightlessness of the object. So, what he told, when any object fall on the surface of the earth due to its gravitation, it feels weightlessness. Means when any object fall freely under the gravity, it is known as it feel weightlessness. What we told that apple fall on the surface of the earth due to force of gravitation. Means earth attracted apple with a force F, that is equal to the gravitational force. We can write it as gravitational constant into mass of the earth, let it is capital M, into mass of the apple, let it is small m, and the distance between the apple and the earth, let it is capital R. This is equal to the radius of the earth we can take. Okay, because the radius of the earth is very nearly approximately equal to the distance of the center of the apple from the center of the earth. So this is the force by which apple attracted toward the earth. Again, from the second law of motion, we know that any accelerated object experienced a force that is equal to the product of the mass of the object and acceleration of the object. Okay. A. Now, in the case of apple, it is falling on the surface of the earth, let with a acceleration, let it is small g. This small g is the acceleration due to gravity. Means the acceleration caused to the apple due to the gravitational attraction of the earth. And the value of g is equal to 9.8 meter per second square. Okay, so here we can replace A by small g. So we can replace A by small g. Now, by equating these two equations, we will get that g capital A into small a divided by r square is equal to small m into small g. Now, will cancel. Then, what we get? The small g is equal to capital G into m by r square. Okay. So, again, we have the value of g, capital G is equal to 6.6 into 10 to the power minus 11. And the mass of earth is approximately 6 into, say, 6 into 10 to the power 23 kg. And the radius of the earth is approximately 64,000 kilometer. Okay. We change it into meter. Then, after solving this equation, we will get the value 9.8, approximately equal to 9.8 meter per second square. Okay, so this is the value of gravity or small g. So what we learn today? First we learn that what is gravitational force. Then we learn what is small g or gravity. Now I also told that when any object fall on the ground under the action of gravity freely, it is known as free fall and the object feel weightlessness during the free fall. So, when an astronaut revolves around the earth with his spaceship, he also feel weightlessness as he is also falling on the ground under the gravity. But his spaceship move around the earth due to its centripetal force. That okay. So now we have the three equations of motion, that are s equal to ut plus half ft square. Already we learned in our previous lesson. Okay. And v square equal to u square plus 2f. Let me write it f. Okay. We have the equation of motion, that s equal to ut plus half at square. These equations we got from our previous lessons of kinematics, where s is the distance, u is the initial velocity, t is the time taken, a is the acceleration, and v is final velocity. Now, when any object fall on the surface of the earth under gravity, the a will replaced by acceleration due to gravity. S will be replaced by the height from which it is falling. And when it is falling, U will be always 0 when it is falling. So what will be the equation of motion in case of free fall? Free fall. In case of free fall, H equal to half g t square, where t is the time taken in falling, and v square equal to 2gh. Third equation, v is equal to g into t. These are the three equations we will have. In the same way, let us find the equations when any object thrown from the surface of the earth. Now I am throwing the stone from the surface of the earth. In this case, when this object will reach to its maximum height, here its final velocity will be equal to 0. Okay. In initial case, we took initial velocity equal to 0 when the object is falling from a height h on the surface of the earth. And now an object is thrown from the surface of the earth with a velocity, initial velocity u, and after reaching a height, maximum height, let it is h, the final velocity of the object will become 0. So what will be the equations of motion? Again, h equal to first one. So here we will write the object thrown. Object thrown. Okay. It will be h equal to ut plus half gt square. Here is the t time taken to reach the height h. Second one, sorry, 1 minute. Here it is moving against the gravity. So acceleration A will be replaced by minus g. As it is moving against the gravity, gravitational force always act towards the center of the earth. But it is moving against the gravity, so acceleration will be minus g. So here plus sign will be replaced by minus sign as g is minus. So let us replace it. Let us replace it, and here it will be minus. Again, next one is v equal to v square equal to u square plus 2gh. Here v is equal to 0. So, and u is the initial velocity, that is equal to u square minus 2gh. From here, we will get the equation u square equal to 2gh. The third equation will be v square equal to, here v square is again 0, v equal to u plus at, means u minus gt. So again we will get u equal to gt. So here are the equations of motion when object will be thrown. Now in your NCERT, there is another topic, the difference between mass and weight. So first one is mass, second one is weight. Okay. So what is the mass? Mass is the quantity contained by the object. The amount of the substance object contain is known as mass of the object. So what will write? When we brought 1 kg sugar, 1 kg is the mass of the sugar. Okay. So remember, mass is the amount contained by the object. And what is weight? Weight is the force by which an object attracted towards the earth. The earth. Next one, mass. If we represent mass as m, then weight will be equal to mg. Third one, SI unit of mass is kg, and SI unit of weight is always equal to the SI unit of force, that is equal to Newton. Okay, that is equal to Newton. So these are the difference between the mass and weight. And weight can change if we change the place. Means if we will go to moon, weight will be 1/6 of the weight of the object found on the earth, because on the moon the gravity of the moon is equal to the 1/6 of the gravity of earth. Okay, but mass will be remain same, always remain same, always remain same. And weight can change can change. Okay, so these are the differences between the mass and weight. This is all about gravitation, children. Next day we'll solve some questions from gravitation. I think this chapter is now easy for you. Thank you.